Hey, welcome back to another video. So today we'll be going over the OSI model. Very important to understand. I think it's something that a lot of people that when they're getting first into cyber, they learn about, they understand it with just IT and cybersecurity, whatever it is, and they just completely forget about it after like a year. They think it's not relevant. I think there's there's a lot of different circumstances that you can actually use this in, and every single step. Me personally, I always think it's either 1 or 8. Most people are going to be like, wow, there's only 7 right there. Can you not count? Well, you forget about yourself. I think that's the number one that usually you overlook something. But I definitely think 1 is one of the biggest ones. If you're working on a switch, router, firewall, some type of server, whatever it is, just check that the light's on. Really, check if the light's on. And then you go through your range of understanding which one's going to be at what point. So, another thing is not changing your IP, making sure, remembering when there's DHCP and DNS enabled, and when those are not there, and you have to configure your own stuff. So, there's a lot of steps that you remember, and as you go farther throughout it, you start remembering where each one is. But at the very beginning, it's very, 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 very good to break it down and go everything with OSI model. So I'll teach you a mnemonic as we go throughout this whole thing. I think that the OSI model breaks it down to a granular level that you're able to digest information, and you're really able to piece apart hey, this is this step, this is this step, and instead of looking at this giant thing, let's just say you have 5 servers connected to each other and 10 switches and a firewall and a core router, and you have over 200 devices on this. You can break it down into an individual section, and then with that individual section you could break it down on, all right, so the physical layer, the cable's all connected. You test the cables beforehand. All right, cool. You know that connection works. All right, now you plug it to both sides. Are you getting lights? So it's breaking it down, the troubleshooting steps, and really being able to digest each interval and being understand and think about what you're doing. So this step worked. Okay, now next step. All right, this step worked. Now next step. And you go through that, and you eventually, it just becomes second nature. So the entire time you're troubleshooting, it's boom, 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 just as that simple. So going through all the different layers, there's physical, data link, network, transport, session, presentation, and application. So with all of this, physical, it deals with the physical connection between devices. So the cables, electrical signals, like I was talking about, just in general, the lights, you're going to see if the cable's destroyed or if it's still intact. Data link layer provides node-to-node data transfer and handles error correction from the physical layer. So every single layer encapsulates the next and able to provide more data, more information that's able to be put together overall. So as you see on the far left of the diagram, there's how the information is transferred, and then you have the center with the squares where is each layer. The right is the type of traffic that's through, and on the far right is the machines that are on that. So the next one, so it goes physical, data link, and then network. So network determines how data is routed between devices across networks, handling logical addressing and packet forwarding. So perfect example of what a router does, exactly, able to get it from your place to the next place, the next hop. So you got that. Got transport layer ensures data is transferred between points accurately and reliably. And this layer can handle error correction and flow control. So at this, as you see, TCP, UDP, how you want the data to be sent over. Whether it's just UDP, a bunch of data all, and just constantly keep on sending, or an actual connection, something that you're actually looking at. So, and that locks in, and you know that you're connected to that device. So you have that. Next, you have session. Session manages sessions and connections between 2 computers, keeping track of which data belongs to which connection. So I got the other day, I was setting up RDP to domain controller, and able to create multiple sessions. That's exactly what that's doing. And so I could have a session, another guy could have a session, another buddy could have a session, and you could have as many as you designate. I designated 20, and so you can have that as many as you want all there. So making it really easy just to understand that. Next is presentation. So presentation is the next encapsulation. So it translates data between the application and network format. It's responsible for data encryption, compression, and translation. So that's where JPEG, MPEG, and GIF, how the pictures, how the videos, how the sound is transferred from one device to another. So that is the file in which is transferred over. So that's presentation. And then application is the actual application that you're using. So it provides network services directly to the applications like email, client, browser, mail, any of that. So a bunch of different protocols to be able to access things, transfer files, move things around, bunch SSH, FTP, RDP, LDAP, all these different things that you can move information around. So there's different ways to look at all of this, but I definitely say I personally start from physical and work my way up. Other people might work from top down, but another one that you always want to remember is person, yourself, on level 8, layer 8. And the reason is there's some, like I was talking about earlier, you might skip a step. So really understand that there might be some things that you're just not locked in on, and that's why it's always good to have a buddy, so you can like really understand what's going on and take it step by step. And then until you get to that place that it's like second nature, you should definitely break it down really slowly. So on the left side, the bits, frames, packets, segments, and data all together. It's how this information is sent across. So I'll talk about that a little bit later. But as of right now, just gotta know that it's bits, frames, and then packets and segments, and then data is the top 3. So with that, hubs and repeaters, very basic level, because they're not really sending any information. What they do is you can put a hub in between 5 computers, and it's gonna, one computer might send data to a hub, and then it's gonna project to the other 4. So they're gonna send it right back out to everyone. So it's going to send that data right back, and everyone gathers that, and it's going to be like, oh, who requested this? And there's no who requested it, why did I get this, so there's no pointing towards, it's just boom. So you send it to the center, everyone gets it. So that's the difference of like a repeater, you'll send data through and it'll just keep on going. Completely different is a switch. A switch, it'll go through it'll go from your port, go up to the switch, and then it'll be like, what MAC address had this? It'll move over, and it'll be like, okay, this is the MAC address that sent it. This is the MAC address that it's destined to. It'll go to that one, and then it'll be like, ha, you received your data. And it's that simple. Like, there's a next level up, rather than just sending, which is what a hub does. It sends it, but being able to send it to an area. That's the difference between a switch, is being able to send it to an area that you actually want it to locate. And then a router is able to look outside, and it's able to look at IPs. So instead of just your MAC address, which is something that's technically with the hardware, IPs can be changed all the time. Same with MAC addresses, they can, but that's besides the point for right now. Just to understand, one is supposed to be to the hardware, the other one is supposed to be logically to the IP. It's supposed to be logically that you're able to assign that, and you're able to move it around if you want. So you can go from networks to networks, and that's the difference between what a router can do. Router and firewall both can go networks to networks. Firewalls protect. I basically think of firewalls as just a protected router. There's a little bit of differences and nuances and specializations between the both of them. Especially when you get an enterprise, you definitely want to have very big distinctions between routers and firewalls. But as of the beginning, when you're just starting out or your home lab, you can definitely have your firewall be your router, and then a switch behind that and able to manage everything. But the big thing about a router is it's able to get from your network, if you only have 3 devices on your internal network. It'll go through your modem, and it'll send information from your modem to another router across, and that'll be able to translate that data. So router can get you from one place to another network. That's the only thing that it does. So we'll go to the next step. And then in here, it's the exact same thing. So A little bit different, but it kind of goes over the actual like port or protocols that are in every single one. So I think that this is pretty awesome to see, because like for physical, you have coaxial, fiber, wireless, hubs, and repeaters, all different ways of transferring the physical layer. Really, really cool. So then you have the data link layer, which uses Ethernet, PVP, switches, and bridges. All transfer data through that second one. So network, you got IP, ICMP, IPsec, and IGMP. Just these are all good examples to really understand transport, TCP, UDP, session, APIs, sockets, WinSockets, and then presentation, SSL. So it's a lot of the encryption, as you see SSL, SSH, IMAP, FTP, MPEG, and JPEG. So all different ways of transferring through files. And then you have end user layer, HTTP, FTP, IRC, SSH, and DNS. So it's that last step. So with that, go here, how the information is encapsulated. If someone sends the information, it's going to build on the data that's being sent. So as you see, if I were to send that data to you, it would go from data and add an HTTP header if you're sending HTTP data. Then from there, it's going to add a TCP header on that next step, and then it's going to add an IP header. And all this does is enable to locate where it's going. So then from there, finally would be a MAC header, and then it's translated into the bits. That bits set across, and then it starts taking information off and de-encapsulating as it goes until it gets to you. So really cool, just being able to see the process, understanding how the flow of information goes when it goes between people. So next step, the differences between the OSI model, which is a little bit older, made in the 80s, and TCP model is made a little bit more recent. The biggest difference is, like as you saw earlier, that the data is being sent between application, presentation, and session. Application is only used to encapsulate all three of those on the TCP IP model. And then on the bottom, you kind of got the data link layer and the physical, but they just call it the network interface layer. So the big thing between that is the network layer on the OSI model and the internet layer on the TCP IP model. That is what deals with like the router and being able to send it outside of your network. But basically the network interface model layer says if it's in your network, anything that it's sending information between that or the coaxial cables or the fiber that you're using, that is all on your interior of your network, not trying to go anywhere. So that's how that looks at that. So this is how I memorized it. I memorized it as there's a mnemonic behind it. And a lot of cybersecurity, especially, and able to remember it on the fly, you want to have a mnemonic, just be able to like remember it just like that. So mine was, please do not throw sausage pizza away, the far left one. I just looked this up trying to find a document that said exactly how I was taught it. But I think this is a really good way of how to remember it, just so you can like, what was the OSI model? Because you might remember like physical layer at the very bottom. And then you're going to start to forget a lot of the middle ones, and you might remember application at the top. But how I remember it is, please do not throw sausage pizza away. But then I also remember SPA on the top section. And that's the two ways that how I do, because I know that the whole SPA is sending data over. And that's the most important, because I group a lot of SPA all together. And you're sending the data, but for the most part, I kind of can break down that the files are being sent and then the applications that are being used. A lot of it's a session that I have to remember. Session and transport, I don't mess them up as much as I used to, but those are the two that I still get. I mess up every so often, but I just say keep on going over that, remember, and try to learn what each section is, and you'll understand, especially once you break it down and using logic between how you're trying to diagnose like technical problems. So, and then this is going back exactly like before, talking about how the information is added on top as it gets encapsulated and de-encapsulated. And then the last is a little story going over this. So If we have to go from the encapsulate or de-encapsulation, we'll go from de-encapsulation rather than encapsulation. So she goes, I think tonight I'll order a pizza for delivery. It sounds so good. And it says the application layer is used interface that receives commands from users. Clicking on a link on the internet browser is akin to a customer dialing on the phone to order a pizza. The presentation layer. Hi, this is a Pizza Palace. What can I get for you? And then she says, I will get one large sausage pizza with veggies. And it says the presentation layer translates requests retrieved from the application layer into a common networking language. In order for a pizza customer to place an order, she needs to speak a common language with the person talking to her. All right, then we have 5, which is session. So it says, okay, that was a large sausage pizza with veggies. That'll be $12.75. It says, this layer can be compared to making a phone call and having the other person pick up the phone. Without another party on the line, no food-related or network-related conversation would occur. So, and then it goes down, it goes to layer 4. Pizza order number 21 is ready for delivery. You can think of the transport layer as a quality control. Suspicious packets will not make it past a firewall. Similarly, low-quality pizzas will not go out for delivery. Layer 3, network. GPS will get me there in no time. It says the network layer determines the best way to route information. Similarly, our pizza delivery will rely on GPS to map out the customer's location. That's exactly how a router works. So it's definitely a big one. Network is how layers get information from one place to another. Layer 2, data. One of the major functions of data link layers to provide a physical MAC address. For the requested information, it can find its destination. Without a physical address, our pizza delivery man would not be able to complete the delivery. Layer 1, thank you for the speedy delivery. No problem. Enjoy your pizza. And it says the physical layer comprises of the physical hardware components in the network. In this final step, our now starving customer will receive her delivery. If you can go over this and really understand it, I think that it helps out a bunch and able to understand the process of how the OSI model works. And overall, a lot of this comes with time. I think that's the biggest thing is like OSI model will teach you a lot, especially if you slowly implement it every single day that you're troubleshooting and working on things, but it's not going to come immediately. I still don't have it after 6-7 years of working in cybersecurity, so it comes with time. You just got to keep on implementing it day to day. But if you like this all and you learned something, let me know. Leave a like, subscribe, comment down below. If you have anything else that you really want me to teach or like go over, or there's any tools or anything that you want me to review, I definitely can look at all of that. But hope you learned something today. Peace. Thanks for watching.